Hello, cloud experts. Today, the cloud computing is the biggest technology revolution around us. This is changing the way how is IT infrastructure is being delivered, how services are being consumed. It is changing all the business models, whether old or new. This also defines how applications are being run and delivered. This is bringing in new opportunities for all the small and big businesses to use data somewhere in the cloud-based services which can be accessed from anywhere in the world. Now, how to tap the cloud computing market? So let us understand what are the technology fundamentals to learn cloud computing, what are the available market options we have, what are the business values it brings to the different kind of businesses, what are the opportunities available, and the risk involved. Now, who should learn cloud computing? Cloud computing, everybody who is working in the high-tech industry should be learning cloud computing. It is not necessary for everyone to become an expert in cloud computing, but yes, you should learn cloud computing, which may be required in your current and future job roles. Now, cloud computing, how we are going to learn. This session is divided into 7 modules. We will start with the journey to the cloud. Now, IT, which is local, to cloud, which is global. The 5 characteristics of cloud computing, 3 service models of cloud computing, 4 deployment models of cloud computing, and benefits of using public cloud services. And finally, we will be wrapping up the session with summary and recap. This is me, Sanjay Kumar, and I have around 18 plus years of work experience in telecom, IT, and cloud industry. Out of that, 12 plus years I have spent in training and teaching. I have trained 10,000 plus students in 50 plus countries, and I am an AWS certified solution architect and a cloud and AWS trainer and consultant. However, this is just a starting point of our journey, and this is long way to go before we become a cloud expert. However, let's get started and start this journey so that we can achieve new milestone in our learning. Hello, cloud experts. So let's start our journey to the cloud. So what is going to be the cloud computing? So in the past, all our hardware infrastructure were kept in some servers in the company offices, and all these infrastructure were having some operating systems and the platforms to run various types of services or applications. All these infrastructure can be accessed by using corporate network, which should be either locally available or you will be connecting via some VPN kind of connection. Now all these infrastructure, platforms and services can be hosted in the cloud, and those resources can be accessed from anywhere in the world by using internet. So what are these services? What are these platforms? What are these infrastructure? We are going to discuss, but all these things are hosted somewhere in the cloud, and they can be accessed from anywhere in the world by using internet connection. So let's see what is cloud computing. So in simple words, cloud is nothing but a remote computer or server which is remotely hosted. However, when we want to understand a technical definition, it is a collection of large computing resources which are typically called as data centers, which are shared pool of resources which can be provided to the end user by using on-demand model. So users can provision these resources as and when required and pay only for the resources what they use in a given time. Now, what are data centers? The data centers are a collection of huge computers and servers with almost infinite capacity. So there are big data centers available which will have lot of computers and servers which will have almost infinite capacity. They are called as data centers. Now, what is cloud computing? As per NIST, which is National Institute of Standard and Technology. Now, cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. That means the computing resources can be networks, servers, storage, application, and services. All these resources can be rapidly provisioned and released with minimal management effort and service provider interaction. That means the user should be able to provision these resources and release these resources as and when required without any human intervention from the service provider. However, this cloud model is composed of various things, which includes 5 essential characteristics, 3 different service models, and 4 deployment models. So we are going to talk about 5 essential characteristics, 3 service models, and 4 deployment models in the next few sessions. Now, what is cloud computing? Cloud computing is all about supply and consumption of IT infrastructure virtually. So all the IT infrastructure which was physically available in the office premises, which is typically called as on-prem data centers. Now all these resources can be consumed virtually from some other location. On-prem traditional data centers, which are typically the data centers available in your office, are moved to virtually hosted environments with state-of-the-art features and services. The features and services which were never possible in on-prem data centers now is possible because of cloud computing resources. Services can be subscribed on demand. So whatever services, whatever resources you need, you can subscribe to these resources in on-demand mode. You can provision these resources and you can release these resources when they are no more required. You pay only for the resources what you use at a given point of time. Data centers are owned and operated by public cloud services. So there are some companies who act as a public cloud provider, and those companies are owning all the data centers and operating all these data centers. Go global in minutes. So once you need these services, you can deploy your services anywhere in the world because these public cloud provider, they come with global infrastructure which is available across geographies. So you can provision your services globally, typically in minutes. Time to market, because you can quickly deploy your services, so time to market for your services has become extremely low. Now, this cloud computing has become a big game changer in IT industry, and it is getting very popular and it has a exponential growth as of now. Now, what are the different type of cloud computing possibility? So there can be somebody who will need a virtual server with some number of virtual CPUs and also some GB of storage. However, this can be some other person or some other business. They don't want to get just the infrastructure but want some applications, some services which are ready to deploy. However, I can have just the requirement of storage where I'm looking for 1000 TB of data storage which can be accessed from the cloud computing resources. Now, what are the typical applications for cloud computing? Today, almost every application what we use in daily life can be, mostly they are hosted on cloud computing. So some of these examples, Zoom, the Google Classroom what we are using for online classes, the Google Drive where we store our file, WhatsApp that what we use on daily basis, the YouTube where we stream all the videos on the daily basis, and Google Meet kind of applications. So almost every application what we use on daily basis are hosted on public cloud infrastructure. Now, what are the leading cloud service provider? So, AWS or Amazon Web Services is one of the leading cloud service provider. What are the other ones? Microsoft Azure, Google Cloud, and Alibaba Cloud. So, let's have a quick comparison between all these. So, if you look at this, the left side picture is called as Gartner Magic Quadrant, where we talk about the challengers, leaders, visionaries, and niche players. So here, if you look at the leader part, so Amazon Web Services is actually one of the leader in the cloud computing market, followed by Microsoft, and after that we have Google. In the right side, if we see, Amazon have 33% market share for the cloud market, followed by Microsoft Azure, which is 18%, and the Google, which is 9% of the market share. So if you look at this, Amazon, Microsoft, and Google together have more than 50% of market share. All these numbers are based on the Q2 of 2020, and they are all published by Synergy Research Group. Thank you very much for joining in this session. Look forward to see you in future sessions. Hello cloud experts. So let us understand how we are moving from localized IT infrastructure to globalized cloud infrastructure. Now, what are the typical problem with the traditional IT infrastructure? Traditional IT infrastructure were mostly on-premises data centers where they were locally available in the customer's offices. How to maintain these data centers? We need to have in-house expertise to maintain and operate these data centers. Any new services and functions or feature used to take a lot of time to market, so it had slow time to market. And it comes with high capex and opex cost. What are the typical life cycle of traditional IT infrastructure? So we used to plan for the IT infrastructure, then used to buy those infrastructure. After that, we are going to install and commission those IT infrastructure in our on-premises data centers, and finally we used to operate them. And this life cycle continues whenever you want to add some more capacities, some more features or functions in your IT infrastructure. Now, what are the typical problems with the traditional IT infrastructure? Now, if you look at this, whenever we want to have some particular traffic, so this particular waveform here shows us the traffic, or I'll say demand of the resources with the time. If we keep our capacity more than the demand, which is typically the need, most of our resources are going to be unused. Typically, they say in the on-prem data center, 76% of the resources are being unused. However, to reduce this wastage, if we try to keep the capacity less than the demand, in this case, there can be two different scenarios. Either we lose revenues because our capacity is not able to meet the demand, so we lose the revenue part of it, or if customers are not happy with the services where they are not able to get the required capacities, the users will leave the system, and finally you're going to lose the users as well. Now, the best way to maintain all these things is to move towards virtualization, where all the compute, storage, and networking infrastructure can be virtualized, and that can be done by using some hypervisor, and all these physical infrastructure can be converted into multiple virtual machines. So VM here stands for virtual machines, and every VM can run their own operating systems and their own applications. Also, virtualization gives us flexibility to increase or decrease the capacities of our virtual machines. Now, it all started with the boom of internet when we started getting lot of services which are available on internet, whether it is Google Drive to store your file, or WhatsApp, which is used for instant messaging, or YouTube, which is used for real-time video streaming, as well as the video streaming platforms. The Zoom, Google Classroom and Meet are required for collaboration and online meetings and online learning platforms. The digital transformation, it all started with the internet, and today whole our world is dominated by internet. So whether it is our camera or our car or our microwave or anything else what we use in our daily life can be connected to internet and using internet extensively. Now, with the advent of big data and artificial intelligence and machine learning, the huge amount of data started flowing in the system, and it becomes really difficult to store this data, analyze this data, and making some required output or some required information, capture some required information from this huge amount of data. The more and more the AI and artificial intelligence and the machine learning started coming to the picture, and that makes it more difficult to manage all the various services by using traditional IT infrastructure. Now, data is considered as new oil, where a huge amount of data to be monitored, data to be measured, data to be analyzed, and data to be secured. So, monitoring the data, measuring the data, analyzing the data, and finally storing this data in the secure and safe manner. Now, what are the new challenges in the changing world? The storing more and more data. The kind of data which is coming to the networks is really huge, and it is getting really difficult to store this data. Analyzing data is equally difficult because this is all huge amount of data, and analyzing this data in real time is getting really very difficult. Now, keeping this data secure, storing this data in a secure manner is another challenge which is coming to the on-prem data centers. To have latest applications, services or functions, we need more and more computing power, which is really difficult with the traditional data centers. You want to market your new services at any point of time, and you need services which have quick time to market, which can be marketed in a very low time. So for that, we need to have some computing resources which are always available to be deployed in minutes. Low capex, we want to keep our capital expenditure as low, and that is the precise reason we want to move towards cloud computing. And zero downtimes. The traditional IT infrastructure can also have a longer downtime sometimes, because all your hardware is deployed locally and you may not have the sufficient expertise to maintain the equipments, and sometimes it can create the bigger downtimes. However, the cloud, which is a global infrastructure, you always have the disaster recovery or load balancing, or I'll say high availability kind of scenario where your downtime can be reduced drastically. Now, bringing in data centers. The data centers, or I'll say cloud computing, is basically a collection of data centers, and every data center is a collection of huge computers or servers which will have almost infinite capacities. What are the leading service providers, cloud service providers? So some of the leading cloud service providers are AWS, which is Amazon Web Services, the Azure, which is a Microsoft company, Google Cloud, and Alibaba. However, we need to have a quick pace of innovation, so we should have the services which are having quick time to market. We should have disruptive technology. The new function and feature should be introduced with lot of new technology advancements, so they can be deployed quickly in the market. Changes in user behavior. The user behavior is changing like anything, and we need to have new functions and feature to adapt to those changes in the user behavior. And finally, all these cloud computing things, all these new technologies or disruptive technologies, they're becoming the new normal in our today's world. Thank you very much for being in this session. Look forward to see you in the future session. Hello cloud experts. So in this session we are going to talk about 5 characteristics of cloud computing. My name is Sanjay Kumar and I'm a cloud trainer and consultant. So as per NIST definition, the cloud computing is all about shared pool of resources, shared pool of configurable computing resources, which can be network, server, storage, application and services. And it has basically 5 essential characteristics, 3 different service models and 4 deployment models. Now in this session what we're going to talk about is the 5 essential characteristics and what are their limitations and the functions and features. Now when I talk about characteristics of cloud, basically I talk about on-demand self-service where consumer can configure the resources the way they want. Broad network access, these resources are available over the internet from anywhere in the world, so you can configure the resources from wherever you want. Multi-tenancy and resource pooling, these resources are actually available for multiple people to use and they are pooled in from various type of server and the capabilities of different kind of hardwares. Rapid elasticity and scalability, these resources can be scaled up and down as and when we need, and the services are being measured so you pay only for the services what you use. So let's move forward and understand what about all these characteristics and what are the different aspects we need to consider when we talk about these 5 characteristics of cloud. On-demand self-service. A consumer can provision the cloud resources according to the requirement and can go global in minutes. Some of these resources can be server capabilities or server capacities, unlimited storage, any services, any software as a service, auto scaling and load balancing. You can scale up and scale down and you can balance the load between different virtual machines. So the user is sending a configuration request and there will be a self-service framework which is available in the cloud and which will allocate the resources according to your need. So resources can be configured by the user itself and it is available all the time. So what can be the different option? So you can configure these resources by using web-based graphical user interface. So you don't really need to know the command lines and stuff like that. You can simply do it by using a browser-based graphic user interface. You can also do it by using some CLI tools, which is command line interface. You can also do it with the RESTful APIs and you can also do it by using some software development kit. So there are various ways you can configure these resources. You can do it with the GUI, you can do it with CLI, you can do it with API as well as some software development kits. Now, broad network access, the second characteristic of cloud computing. All cloud resources are available for configuration from anywhere in the world with variety of clients and devices like mobile phone, laptops, desktop. So you can configure these resources by using any devices, whether it is a mobile phone, laptop or desktop. We can modify, monitor and add, change or delete these resources at any point of time from anywhere, and it comes with a lot of security feature as well. So what do we mean by that? You have infrastructure available, you have platforms available and your services available, and all these things are configurable from anywhere in the world by using a simple internet connection. Resource pooling. The cloud is composed of many different servers which are pooled in, and all those capacities are combined so that they can be provided to n number of different users. So what benefit we get out of it? The benefit what we get out of this is EOS, economics of scale. When millions of users are actually using the same resources, so it will have the less cost to the service provider, as well as it will give the benefits to the end users. So these resources can be compute resources, can be storage resources, and can be networking resources. All these resources are pulled in, and on top of this we are running some hypervisor and creating some virtual machines. Every virtual machine can be given to one user, and one user can get more than one virtual machine as well. One application can get more than one virtual machine. Every different virtual machine can have a different type of operating system and can host n number of applications which are user specific or customer specific. Resource pooling. Now resource pooling also allows me to have multiple tenancy. That means n number of users are accessing the same pool of resources. Out of these resources, some can be shared and some can be dedicated for one particular customer. Just to give you an example, this particular server can be allocated to only this particular user, but these two users can be sharing the same hardware. So we have possibility to have dedicated host as well as shared tenancy. Now resource pooling. A lot of computing, storage, networking resources are pooled in to create bigger virtual environments and assigned to many customers in multi-tenancy models, and are released when they are not required anymore and just charge for what is being used. So what is actually happening here? We have created multiple virtual environments and assign them to n number of different customers in multi-tenancy model, and we will release these resources whenever somebody is not using it, so that we will charge the user only for the services, only for the capacities what they're going to use. It also gives an option and flexibility of choosing resources based on the choice, based on the latencies, based on the consumer experience, the geolocation, and also based on the government regulation. If government regulation wants to have your resources in a given geographical area, it also gives you flexibility to have your data only in a certain geographic location. The exact location of these resources may or may not be known by the end consumer. So it depends on your services, but exact location of these resources may or may not be known by the end customer. Rapid elasticity. So what do we understand by rapid elasticity? Capacities can be elastically provisioned and released. So all the capacities what you need can be increased and can be decreased whenever you need it or whenever you don't need it. So for example, in some cases it is done automatically to scale rapidly outwards and inward with demand. So you can increase the capacity whenever demand increases, and it will decrease the capacity whenever demand is decreasing, and you will only pay for the capacities what you are going to use. Minimize the cost of resources of not being used. So you will not pay for the resources what you are not using, you will pay only for the resources what you are using at a particular time. Increase capacity for spike in traffic. This is particularly useful when your traffic is bursty in nature and you need to increase the capacity whenever there is a spike in your traffic. Otherwise you can keep your capacities low. Quick time to market new services. Because you can increase or decrease the capacity whenever you want, you just need very less time to market new services to your customers. Now how do we understand this? So if we go with fixed capacity, now when we have the fixed capacity and our traffic is like this, which is changing across the time, now we are actually wasting a lot of resources. All these resources are being wasted. So typically they say in fixed capacity kind of environment, you waste 76% of capacity. So 76% of the capacity is being wasted whenever you go with on-prem data center or whenever you go with fixed capacity. However, in case of rapid elasticity, in case of cloud computing, your capacity can be increased or decreased or increased or decreased whenever your demand is changing. So we will change the capacity as and when our demand is changing, and we will only pay for the resources what are being used. Now, provision resources, you initially provision the resources and configure something called as scaling. There are various ways to configure scaling, but the easiest way to do it is called as auto scaling. Auto scaling means it will have some thresholds, and whenever those thresholds are being breached, you will increase or decrease the capacities. So whenever you are monitoring the resources and whenever you are actually need more capacity, it will be scaling up the resources, and whenever you don't need those capacity, it will be scaling down those resources. So you can move to, let's say, X resources, so you can increase it to 2x resources, or if you don't need it, you can actually reduce it to x by 2 resources. So you can increase the capacity whenever you need it, you can decrease the capacity whenever you don't need it. The major services, so every service which is being used in a cloud environment is being monitored, controlled, reported, and it provides transparency both to the provider and the consumer of utilized services. So you know these usage can be monitored in terms of storage what you are using, processing what you are using, the bandwidth requirements, and also the active user accounts, and there can be n number of other parameters which can be used for a major services, and you pay only for the services what are being used. Now this is the NIST definition. So major services, pay as you go, you only pay for the services what you use, server capacity used, operating system being used. If you use Linux, the charges are going to be different. If you use Windows, charges are slightly different than that. Location and regions where you are actually storing your data and where your services are being hosted is something will also impact the money where you pay. Type of storage and capacities, high availability, durability, accessibility, what kind of storage you use and what kind of capacities you use, that will also impact your final payments. Bandwidth consumption, what kind of bandwidth you consume, and what kind of support you need from the cloud provider, that will also change your payment. And number of requests for read and write. So this is another thing what will impact your payments. That's all in this session. I hope you enjoyed the session. Look forward to see you in the future session. Hello cloud experts. So in this session, we are going to talk about 3 different service models of cloud computing. So what are these 3 service models and what do they really mean? We are going to talk about in this particular session. Now what is cloud computing? As per NIST definition, it is about shared pool of configurable computing resources, which may include network, servers, storage, application, and the different services. The cloud model is composed of 5 essential characteristics and 3 different service models and 4 deployment models. In last session, we talked about 5 essential characteristics, and now in this session, we are going to talk about 3 different service models. So what are these 3 different service models? If we talk about it, these 3 different service models are called as IaaS, which is infrastructure as a service, PaaS, platform as a service, and SaaS, which is software as a service. Infrastructure as a service, platform as a service, and software as a service. Now, in case of infrastructure as a service, you simply need to move all the platforms and your services to the cloud computing provider. However, in case of platform as a service, you just need to use the infrastructure and the platform of the cloud provider. You just need to build your application on top of cloud computing infrastructure. However, in case of software as a service, there are some ready to use services which are available with the cloud computing infrastructure, and you can simply use it. Now, just to take an example, in case of infrastructure as a service, it can be related to virtual CPUs, RAM, storage, or networking. However, in case of platform as a service, you can have some app development tools, some runtime environments, integration, OS images, etc. In case of software as a service, it can be some notification services, queuing services, SMS, emails, workflow. So these are the 3 different service models which are called as infrastructure as a service, platform as a service, and software as a service. So let us understand these three different service models one by one. Now in infrastructure as a service, the cloud infrastructure provider is providing you the computing, storage and networking resources. So basically it is providing you all the hardware capabilities which are available. And in case of platform as a service, the cloud provider is providing you frameworks and platforms to develop software and application. In case of software as a service, the cloud provider is providing services which are available for the end user. So three different service model. In case of IaaS, I'm giving you the infrastructure. In this one, I'm giving you the platforms. In the software as a service, I'm giving you the services which are ready to use. Now let us understand in case of traditional IT environments. In case of traditional IT environments, whether all the things end-to-end managed by the customer. So whether it is networking, storage, server, virtualization, operating system, middleware, runtime environments, data and application, each and everything is actually used by the managed by the customer. So in this case, the cloud provider is not into the picture, so we have absolutely no responsibility. It is a traditional IT which is also called as on-prem data center, on-premises data center, where everything is managed by the customer himself. Now what is the typical problem? What you need to have is you need to have all the hardwares in place. You also need a physical locations to install those hardwares, manage those hardware, as well as you need to have capability of each and every component which is mentioned here. Now how do we really move forward with the cloud infrastructure? Let us understand this. So complete responsibility lies with the customer himself. Planning the hardware, buying the hardware, installing, managing the hardware, all these things are done by the customer. Managing security of infrastructure, real estate requirement, the installation location where you will install these servers is again with the customer. Upgrades of the hardware, patches, fault, performance management, all these things are actually managed by the customer himself. Now moving towards infrastructure as a service. So in case of infrastructure as a service, the first four components what we see in this picture, which are networking, storage, servers and virtualizations, are actually passed on to the cloud provider, and where customer takes care of the remaining functions like operating system, middleware, runtime environments, data and application. So in case of infrastructure as a service, the physical infrastructure part is actually passed on to the cloud provider, and in this case all other things related to the platform and the softwares are actually managed by the end customer itself. Now infrastructure as a service, shared responsibility between the customer and the cloud provider, where cloud provider is taking care of the infra and customer is taking care of the platform and services. So it is a shared responsibility between the customer and the cloud provider, where provider takes care of hardware resources and customer takes care of the OS, runtime environments, platforms, as well as configuring and managing virtual resources, pay-per-use and all this stuff. In case of platform as a service, some more functionality is actually passed on to the cloud provider. So in this case, operating system, middleware and runtime environments, all these things are passed on to the provider itself. The customer is taking care of only the applications and data of end users. So in case of platform as a service, some more responsibility is passed on to the cloud provider and some less responsibility remains with the end customer. So what we did here, we have also transferred platform responsibility like runtime environments, middleware and operating system to the cloud provider. Now in case of platform services, the provider takes care of hardware resources as well as the OS, runtime environments and platform. However, the customer configuring and managing virtual resources, customer will take care of building software, applications and managing end-to-end operations, pay for the usage what they're doing with the platform. However, the charges are going to be little higher compared to infrastructure as a service, but now because now you are also using the runtime environments, operating systems and stuff like that. Now, some examples: Elastic Beanstalk, App Services, Google App Engine. These are some of the examples for platform as a service. Now, moving on with the software as a service. In software as a service, the end user application, the software itself, are given by the provider. Now, in this case, provider is simply giving you end-to-end stack, which is shown here, starting with networking, storage, server, virtualization, operating system, middleware, runtime environments, data and application. Each and everything is managed by the cloud provider. The customer is not actually concerned about the infrastructure, platform as well as the application. The customer just need to pay for the services what are being used. So how do we really divide the responsibility between the customer and cloud provider? Provider takes care of almost everything what we have discussed, whether it's the hardware resources, platform, configuring and managing virtual resources, providing software, and customer only pay for the usage what they're doing on those applications which are being used. So some examples of this is Office 365, Google Drive, Amazon Poly. These are some examples of software as a service. So that's all we have in this session. I hope you enjoyed this session. Look forward to see you in the future session. Hello cloud experts. So in this session, we are going to talk about 4 different deployment models for cloud computing. As per NIST definition, what we have is 5 essential characteristics, 3 different service models, and 4 different deployment models. In the last 2 sessions, we have talked about 5 essential characteristics and 3 service models. If you have not seen those sessions, please go ahead and watch those sessions as well. And in this session, we are going to talk about 4 different deployment models for cloud computing. Now, what are these 4 different deployment models? So these 4 deployment models are called as public cloud, private cloud, hybrid cloud, and community cloud. Now, we are going to talk about all these different deployment models one by one. Now, in case of private, the network infrastructure, the hardware infrastructure is actually managed by one particular organizations, right? So what we are having here is there is one organization which is having their own cloud which is used only for their own purpose. This is not available for other organizations and other users. In case of hybrid cloud, the private organization is using some on-prem data centers as well as using some cloud capabilities. So they are relying on both. They have some on-prem data centers, some capacities which are available in on-prem data center, and they are also relying on cloud computing. In case of public, the infrastructure, the cloud infrastructure is available for anybody and everybody to use and consume. So these public resources, public cloud resources are available for anybody and everybody who wants to use these resources. So let us understand all these cloud deployment models one by one. So in case of public cloud, cloud services are available for anybody and everybody. The cloud provider will own, manage, operate and troubleshoot all resources in their own facility. In this case, what they will have is their own facility. They are something called as data centers, big huge data centers. They will be owned by, managed by, operated by and troubleshooted by the cloud provider. Allocating resources on demand and releasing when not required. So you can allocate the resources whenever they are required and you can release the resources whenever they are not required. Charging only for the capacities which are being used. So in public cloud, you will charge only for the capacities which are being used by a particular user. Public clouds are multi-tenant and shared resources. So one particular hardware can have multiple users, multiple tenants, and these pools are created by using n number of different data centers or servers. So all the resources are being shared by multiple tenants. Pay as you go, only pay for the services what you are using. Go global in minutes, so it allows you to go for global services in minutes. So you can provision your resources globally. So if sitting here in one geographical location, if you want to configure resources in some other region, in another geographical region, you can do it typically in minutes. Resource shared between multiple customers. So multi-tenant means resources can be shared between multiple customers. Now just to take an example, we have a cloud infrastructure where they will have something called as their own virtual private space. So they have something called as virtual private space, which is available for the user customer A, customer B, customer C. So some of these resources can be dedicated and some of these resources can be shared by multiple users or multiple customers. So in this scenario, we have a big cloud infrastructure, and in that we have created smaller chunks of cloud resources which are being used by customer A, customer B and customer C. Now multi-tenancy and shared resources. Now just to take an example, public cloud, AWS, which is the leading cloud computing company, has a global infrastructure where they have 24 regions available, 24 different regions available, and in those 24 different regions they have 77 availability zones. So every region typically have 2 or more availability zones. So in that case, whenever one availability zone fails, other availability zone will be available and your data will be replicated across availability zone so that you never lose your data. It has 216 point of presence, which is like edge location, and 11 edge caches. We will talk more about it in our AWS course. It is serving more than 245 countries and territories. So it has got a geographical global presence available. So you can use the resources sitting in one geographical location. Let's say in India, you can actually use the resources in America also, if you have your user base in America. 3 different service models, we have already talked about it. We have 3 different service models for the cloud, called as the infrastructure as a service, where you are using just the physical infrastructure. Platform as a service, where you are using infrastructure as well as the platform. And the third one is called as software as a service, where you are using application as it is. So underlying hardware, underlying platform as well as the services are being used by the end users or customers. Now, what are the typical services? These services can be compute based services, where we have virtual servers, virtual containers, serverless architecture computing and runtime environments. Networking resources, where we talk about firewalls, virtual private clouds, load balancers, DNSs, internet gateways, content delivery network. Storage, where we talk about object based storage, file storage, block storage, life cycle management of storage, replication across regions as well as backups. In case of databases, we have relational as well as non-relational databases, data lakes, data warehouse, memory caches as well as big data frameworks. In case of security, we have access management, DDoS protection, resource audit, services audit as well as multi-factor authentication. It also gives us a lot of features related to AI, artificial intelligence and ML, which is machine learning. So it gives us resources and features available for artificial intelligence, machine learning, deep learning, speech recognition, text to speech, speech to text, emotional recognition and n number of other services which are available on public cloud services. In case of private cloud, you have your own private data center which are available on premises, but what you do is you use virtualization kind of technique and bring in the cloud capabilities, and finally what you will get is on-premises data center with cloud capabilities available for only single organization. So basically it is an on-prem data center with some cloud capabilities. This is what something we call as private cloud. Now private cloud, it will be operated by and operated for a single organization, called as private cloud or corporate cloud, usually hosted in customer premises, which is also called as on-prem data center, mostly used by organization which has existing data center and running some mission critical applications. Now benefits of private cloud, it will give you better services because all the resources are available for you. Cloud service enablement, you have also enabled some of the services, but this particular benefit is not a completely a great benefit because you are really not it is really not possible to have the public cloud kind of services in private cloud. Cloud aware application design, so you can design your application based on the cloud infrastructure. Security is in your own control, so you can have the security mechanism based on your requirement. and it gives you more control over hardware, security level, and provisioning new services. And the capacities are dedicated for one particular on-prem private customer. Drawback of private cloud: it will have upfront capital investment. So whenever you want to build your own cloud, you need to make some upfront capital investments. Lot of hassles in planning, buying, installing, and managing hardware. Operational cost: you will have lot of operational cost to manage these hardwares. Limited capabilities, bound by the hardware which is available, and no state-of-the-art security features. So you will not have advanced functions, features, as well as security features, because this is specially designed for one particular organization. Now, hybrid cloud: what happens whenever you have some on-prem data centers and now you want to expand your capacity, and for those expansion of those capacities you move to the cloud environment. That is where we call it as hybrid cloud. So hybrid cloud is a mix of public and private cloud, can be used for capacity expansion. Existing resources can be utilized, so you are actually using your existing resources of your own data center as well as using additional capacities of cloud environment, and additional or temporary workloads can be offloaded to the cloud. So you can actually offload your additional capacity requirements or your additional workloads or temporary workloads to the cloud. So you use your resources which is available on-prem, and for additional capacities or workloads you are actually going to the cloud environments. And batch processing kind of environments where you need big processing, you can go for cloud computing for these kind of different applications. Community cloud is provisioned for exclusive use by specific community, which consumer comes from organization. These can be mission related, security requirement related, policy and compliance related. So some of these missions can be government missions, some healthcare missions, some social missions, and some welfare missions. So these are some of the examples where n number of different users coming for the same mission, and they are actually consuming some resources from a particular cloud. So this may be owned by, managed and operated by one or more of the organizations in the community, or it can be managed by a third party or some combination of them. Right. So in this case, what we are using exactly the public cloud kind of environments, but now they are not used for some commodity, some customer requirements, but they are created for some social welfare or some mission related different requirements. That's all what we have in this session. I hope you enjoyed the session. Look forward to see you in the future. Hello cloud experts. So in this session, we are going to talk about benefits of using public cloud. So let's get started. As we understood, what is cloud computing? Cloud computing, as per NIST definition, it is enabling ubiquitous, convenient, on-demand network access to the shared pool of configurable computing resources, and those resources can be networks, servers, storage, applications, and services, which can be rapidly provisioned on demand and released with minimal management effort or service provider interaction. So without any interaction, without any intervention from the service provider, these can be provisioned as well as released. Typically, cloud model consists of 5 essential characteristics, 3 different service models, and 4 different deployment models. In last few sessions, we have talked about essential characteristics, service models, and 4 different deployment models. Now, in this session, we are going to talk about the benefits of using cloud computing, and especially the public cloud infrastructure. Now, first and foremost important aspect of public cloud is elasticity and scalability. That means the resources are virtually infinite, so you can provision the resources whenever you want it, and they are always available, and these provisioning can be done manually as well as in some cases it can be done automatically as well. Scaling up and down and out and in as and when required, so you can scale up, scale down, scale out, scale in as and when required, and you can also define some auto configuration policies when these scaling up and scaling down things can be done automatically as well. Pay only for what you use, so you only pay for the resources what you actually use. So you just need to configure the resources, pay for those resources, and release the resources when you don't want it, and don't even pay a single penny for that. These resources are accessed from anywhere, and you are sitting anywhere in the world with any computer, any laptop, any mobile phone. You can provision these resources and you can release these resources. Access from internet, web console, CLI, command line interface, APIs, SDKs. So there are n number of ways to access these resources. You can do it through internet by using some web GUIs, some CLI command line interface, some APIs, and some software development kits. Real-time alerts for resource users. You can also set up some threshold where you can get the real-time alerts for the usage of your resources. Automation. You can define something called as auto scaling, load balancing, and stuff like that, so your resources can be automatically managed. Real-time monitoring of resources and updation. So you can also have real-time monitoring for resources, the use of resources, as well as the updation of the resources. Economics of scale. It is relevant for both the cloud provider and the end user. Cloud provider will gain out of the economics of scale. That means the millions of customers what they have, those customers are able to share the resources as and when we want. So benefit for customer, you just need to focus on business requirements, no need to focus on IT infrastructure. Minimize the cost. Your cost can be minimized because you are sharing your resources with millions of other customers for that same cloud provider. It is also, you can quickly market your services, and this reduces your time to market. World-class infrastructure and products and services. So because public cloud providers are serving millions of customers, they will always come up with world-class infrastructure as well as product and services, which is very difficult to deploy in your private cloud or on-prem data centers. Benefits for cloud service provider. Better resource utilization for many customers because millions of customers are using their resources are utilized in a better way. Operational efficiency, because they have lot of resources to manage, they have to bring in operational efficiency. And great pace of innovation and disruptive product and services, because they have a lot of customer and there are a lot of demands from different customers, which increases their pace of innovation and also brings in disruptive products and services. Go global in minutes. You can introduce global services in minutes. Cater to users across geographies. You can cater to users which is from one geography to another geography. Best content delivery networks for enhanced user experience, because you have global customers, right? So you can have the content delivery network which enhances your user experience and global presence. They have globally available data centers, and because they have this kind of global presence, it also gives you a possibility to have high availability for your resources and high durability. You can replicate your resources in multiple facilities, and that also assures that you have your resources are highly durable. And put together all these things, you can have a global reach by using a single click. Getting more and less. The cost is always important for running your business. So we always, as a business, we always need to balance between capex and opex. However, cloud gives you functionality to have almost zero capex. So your capex is almost zero because you don't pay anything upfront. Yes, there is a possibility where you can have some upfront investments in cloud, public cloud also, but you can start with almost zero, and without having any capex, all the cost will be there in opex. And even OPEX will go low because you pay only for the resources what you use, not for all the resources what you want to use after 3 months or 6 months. So it is based on the utility pricing, metered pricing they call it. So you pay only for the resources what you use. Pay as you go model, only pay when you use. Reducing capex, it makes your capex almost zero because you don't pay anything upfront. No worries about hardware life cycles. You no need to change your hardwares or talk about worrying about the hardware life cycles when those hardware will go out of life, end of life. You need not to worry about this, and all these things will be managed by the public cloud provider. No worries about real estate, where you are going to install those hardwares, how you are really going to manage those hardwares. Those are not for you to worry. Those things are taken care by the public cloud provider. No worries about software updates and patches. All the things related to software update, patches, if you are using PaaS and SaaS kind of models, all these things will be taken care by the hardware provider, the public cloud provider itself. And no long-term commitment. You can close your resources, you can terminate your resources whenever you don't need it, and that's what there is absolutely no long-term commitment with the public cloud provider. So these are some topics where we talk about CapEx versus OpEx. Global great reliability, multiple data centers in different regions. So they have n number of different data centers. So just to just to give an example, the AWS has more than 200 data centers available across 13 or 14 different regions. So the data centers are available in various regions. Your data is kept in multiple facilities, so that gives you help in the disaster recovery and high availability. Failover mechanism, you can also define some failover mechanism where whenever one data center is not available, your workloads can be running over the another facility. So you have some facility to have failover mechanism as well. You can also do load balancing between different availability zones or different data centers so that your resources are always available. And these public cloud will also come up with strict SLA. So typically they say 99.99% availability. 99.9999, they say it 11 nines kind of durability. So that means if you upload 10,000 files on a AWS cloud, there are chances that in 1 million years one particular file may not be available. So their availability is something which can never be achieved in the private cloud or on-prem data centers. So high competition between cloud service providers, and that helps them to innovate and provide new services to their end customers. And all these things are related to the global skill infrastructure. Business agility, so you will have always the latest hardware, you will have the latest software or latest applications, latest products and services, quick time to market, and no forecast or prediction. You need not to forecast your capacity for 1 year down the line or 6 months down the line, because you can increase it whenever you want it and do whatever you want whenever you want. So you really need not to worry about the timing. You can market new services, you can deploy new workloads as and when you want, and without any intervention from the public cloud provider. And it gives you competitive edge for your business. So what you need to do is, you really need not to worry about the hardware part of it, the infrastructure part of it. You just need to focus on your business goals, your primary business goals. And all these things are related to the quick adaptation for the new services or products. Security, people give some logic that public cloud is not secure compared to the private cloud, but actually it is other way around. So the kind of security features, the kind of the features related to security, authentication and authorization, what we can have in public cloud, it is almost impossible to have those in private cloud or in your on-prem data centers. So it comes with a hell lot of services related to security, and that gives you lot of benefits compared to other private cloud or maybe on-prem data centers. Some of these are a state-of-the-art identity and access management, key management services, various types of keys and how those keys are being managed, multi-layer security with security gateways, with firewalls, with the n number of other applications. You get a multiple layer of security at lower layers, at the application level, at the VPC level, and n number of other stuff. Password rotation policies, you get a lot of password rotation policy, how are password being managed and how your passwords are getting expired. Resource service auditing, you have some applications, they will keep on doing auditing for your resources or your services, and those reports can be analyzed to make proper security decisions. You also have some applications which gives you DDoS protections and stuff like that. Firewalls, access lists, security groups, they all add up to multi-layer security. So multi-layer security means you have a number of different mechanisms to provide security features for your resources on the public cloud. And real-time notification, whenever your threshold are breached, you will always get some real-time notification for your security breach as well. This is all about best security technologies which are available in public cloud, which is hardly possible to implement in private cloud or in on-prem data center. So this is all what we have in this session. I hope you enjoyed this session and look forward to see you in the next session. Hello cloud experts. So now we are approaching towards the end of this session. So in this session we are going to talk about the points that we have discussed and a quick recap on all those points. So initially we started with what is cloud computing as per NIST definition. So we talked about NIST definition, where cloud computing is nothing but a shared pool of configurable computing resources which can be deployed or released with the minimal intervention from the cloud service provider. Now cloud model is composed of 5 essential characteristics, 3 service models and 4 deployment models. So in last few sessions we talked about 5 essential characteristics, 3 service models and 4 deployment models, and we also talked about the benefit of using public cloud. So what is cloud computing? Traditionally all the services, platforms and the infrastructure are being hosted in some on-prem data centers which are typically locally managed by using a corporate network, and you need to manage all these things end to end. However, in case of cloud computing, all these infrastructures, platforms and services can be hosted on cloud provider, the cloud infrastructure, and all these resources can be accessed over internet from anywhere in the world by using variety of devices like mobile, laptops and desktop computers, and they can also be accessed via web GUI, APIs, SDKs or some kind of CLI based tools. Now we talked about 5 characteristics of cloud computing, where we talk about on-demand self-service. These resources can be created whenever required and by the customer itself. No need to have any intervention from the cloud service provider. Broad network access. These resources are available from broad category of networks and devices. Like for example, from internet you can access all these resources, configure these resources and release these resources whenever you don't need it. Multi-tenancy and resource pooling. These resources are actually pooled in and they support multi-tenancy, where multiple users can share a pool of resources. Rapid elasticity and scalability. These resources can be increased or decreased whenever you need it, and this can be done manually as well as automatically. And all these services are measured, so you only pay for the services what you use. 4 different deployment models. We talked about public cloud, private cloud, hybrid cloud and community cloud, where public cloud talks about these resources are available to general public and anybody and everybody can use it. However, private cloud is only for a certain organization and managed by the same organization. Hybrid cloud is a mix of public and private cloud, where you have your on-prem data center or your own private cloud, and you are actually collaborating with public cloud also, and you are using public cloud for additional workloads, additional capacity what you need for your workloads. And community cloud is a community specific cloud which is used for some social welfare, health or some social and government regions. 3 different service models we had. We had infrastructure as a service, where we are just using the physical infrastructure, which may be in the form of vCPUs, RAM, storage or networking. So you need to move your platform or your services to infrastructure which is provided by the public cloud service. PaaS, which is platform as a service, which is typically app development tools, runtime environments, integrations, OS images. You need to build your application with this, so all the platform and underlying infrastructure is a part of platform as a service. Now the third one is called a software as a service, where you have ready to use services which is available and you can just go ahead and use these services. Also all the services, all the platform required for those services and the infrastructure required for those services, they all come under software as a service. Three different service models: infrastructure as a service, providing computing, storage and networking resources virtually; providing frameworks and platforms to develop software and application; and finally providing services to the end user. So these are three different service models what we have for the cloud. So just to understand this, so in case of traditional IT, all these functions are typically managed by the customer itself. However, in case of infrastructure as a service, the infrastructure part is managed by the cloud provider and all the other things related to the platform and the services are managed by the customer itself. In platform as a service, this part is taken care by the cloud provider, which is related to the infrastructure as well as the platform, and only the application part of it, the software part of it, is managed by the customer. In case of software as a service, the end-to-end management is done by the cloud provider. The customer is only using the softwares and only paying whatever he is using. Benefits of using public cloud: so you can increase or decrease capacity whenever you want, so it gives you a lot of flexibility and elasticity and scalability. Economics of scale: you can have different very huge data center with almost infinite capacity. You can deploy your service globally typically in minutes, getting more and less, so your cost capex is very low, capex is almost zero, and your opex is also very low compared to your on-prem data centers or your private cloud. Great reliability, because they come with state-of-the-art hardwares and softwares. It gives you a lot of reliability, lot of new features. It gives you business agility. It gives you state-of-the-art security features as well. And who are the leading cloud service provider? Right, AWS is one of the leader in public cloud services, followed by Azure. Azure is the next one, and Google Cloud and Alibaba. So these are the four companies which are the leading cloud service providers in the world. That's all for this session and for the course. I hope you enjoyed this session as well as the course. Look forward to see you in future sessions and future courses.